So let's find the value of A0, the constant. If we look back at our square wave, consider this period here. So over one complete cycle between minus pi and plus pi, well, it's 0 here, and then it's 4, and then it's 0 again. You might guess what the average is, what the average voltage would be over this cycle. What we're going to do is do the integral and actually find out what the average is. So, what do we do? 1 over 2 pi, that's the period between minus pi and pi, of the integral between pi and minus pi of the function. That's what we're going to do. However, we think about that square wave function. Again, let's look back at it. It's 0 between minus pi and minus pi over 2 and pi over 2 and pi, so we're actually only interested in this period here between minus pi over 2, pi over 2. So we only actually need to integrate between pi over 2 and minus pi over 2 of the function between those 2 points, which is just 4. It's just a constant, 4 volts. So I integrate 4 between pi over 2 and minus pi over 2. Well, integrating 4 with respect to t gives us 4t. So now I just have to put the limits in between pi over 2 and minus pi over 2. So I put them in here. Minus times a minus gives us a plus, so we end up with 4 pi over 2 plus 4 pi over 2, which is 2 pi plus 2 pi, which is 4 pi. So we end up with 4 pi over 2 pi, which cancels down to just 2 volts, which you may have guessed it to be. So in other words, we're just confirming that the average over a complete cycle is 2 volts. Now we're going to carry on and work out what the Fourier coefficients are for the harmonics.